Okay, so we are starting piecewise functions, and we're going to be graphing them today. So let's start off with what we know. I know that f of x can just be thought of as y. And so my first equation is y equals x. So I'm going to go ahead and graph that. Let's start off with what we know. So the line y equals x starts at the origin, and then it goes up 1 over 1 from there. So I'm just going to draw my graph, and I'm also going to go this way to the negative side. Sorry, not all of my dots are accurate. There we go. Okay, so that's my first line, and I'll go ahead and connect my points there. That is the line y equals x. Now, I want you to notice the constraint that we have. It's saying that x is less than or equal to 3, or negative 3. So they only want the line y equals x if x is less than or equal to negative 3. So let me show you where the x-axis is. It's right here. And the values, or the x value negative 3 is right here. This means that I only want y equals x if x is less than or equal to negative 3. That means I do not want this side of the line because those x values were bigger than negative 3. So I need to be to the left of negative 3. Okay, so let me draw that line back. I will have a closed circle at negative 3. Okay, so that's my line. Let's go ahead and graph the next one. I'll do this one in red this time. This one says y equals negative 2x plus 1. So go to the y-axis at 1, put your point, and I'm going to go down 2 over 1. So these are my points on my line. And then I'll just go ahead and connect my points. So this is my line. Again, this one is saying x is greater than negative 3. So on my x-axis at negative 3 is right here. I only want the part of the line that is to the right of negative 3. I only want x values that are bigger than negative 3. So that means I'm going to erase this part of the line because those x values are smaller than negative 3, and I want them to be bigger than negative 3. Okay, let me explain what I mean by this. This point right here, that point, the x value is negative 1. This point right here, the x value is 0. This x value here, the x value is 1. So all of these points on this line, the x value is greater than negative 3. Okay? Now notice there is not a line underneath. So we cannot equal negative 3. We just have to be bigger than negative 3. So that means, that means that at negative 3 on this line, I will have an open circle. Okay? So let me clean this graph up a bit. Okay. All right, so that is my piecewise function. Let's talk about domain and range. Remember, domain is all the x values, okay? Domain is all the x values that are represented here, okay? All the x values represented. Okay, so that's what the domain means. So let's look at the domain. The x values that are represented here, I know it's going to the left forever because there's an arrow here. Well, all these x values, if you keep going to the left, you'll go to negative infinity. And whenever you have an infinity symbol or an infinity sign, you use a parenthesis. And then it goes all the way to negative 3. And there's a closed circle here, so we can include negative 3. Negative 3 is represented. And then it picks up here and it continues to go to the right. And it goes on forever. So it looks like it goes from negative infinity to 3. Negative infinity to infinity for the domain. Now, I know what you're thinking. There's an open circle here. So isn't it all the x values except for negative 3? But no, there's a closed circle right here. So negative 3 is represented on this line. It's just not represented on this line. And then all the numbers past negative 3 are also represented on this line. Okay, numbers like negative 2.99, negative 2.98, those are included on this line. Okay, so that is the domain. You could also write it as all real numbers. Okay, now let's look at the range. I'm going to try to erase some of this without getting rid of my line. Okay, so let's talk about the y values. Okay, let's see what y values are represented in this graph. First of all, this is going down forever, okay? So that means it's going down. All the y values are going towards negative infinity. And then it goes up to 3 or negative 3. But look, these points are also included in the y value. So we don't stop here. We have y values represented here too. This is the y value 1, the y value 2. It goes all the way up to up here. And I believe that is 1, 2, 3, 4, 5, 6. That's 7. So the very top of the graph is at 7. So that is your range. You could also write it as y is less than 7. Okay, so I know that was a lot. Let's go ahead and do another example so that this concept can sink in. Okay, so let me scroll out of here. Let's scroll up. Okay, so again, let's go ahead and graph this line. So we're going to go to negative 7. 1, 2, 3, 4, 5, 6. So negative 7 is right here. And then we go down 3 over 1. So that would be off my page over there somewhere. So I'm going to go this way and put my points. Okay, so that's my line. Now, it's saying that it wants this line only if x is less than negative 1. So let me show you. This is x at negative 1. Okay, this is the line x equals negative 1. Okay, so we only want things that are less than negative 1. So I'm going to erase this side of my line, and I'm only going to keep this line, and it's going to be an open circle because there's no equal sign under here. See, there's no equal sign. It's just less than. And I'm going to go this way. This is my line, and it only includes x values that are less than negative 1. Now let's do the other one. This is saying y equals negative 5. Okay, we'll go to the y-axis at negative 5, and we'll draw a line there. So here is 1, 2, 3, 4, 5. Here's negative 5. This is the line y equals negative 5. This is the line that goes through negative 5 on the y-axis. Now, it's saying that it only wants this line for x values greater than or equal to negative 1. Okay, so here's negative 1 right here. I only want the x values that are greater than or equal to negative 1. So I can erase this side over here. I don't need this side. I only want the right side. And I'm going to do a closed circle there because it says greater than or equal to negative 1. So that means my line would start here and it would go this way. So that is the piecewise function. Okay, so let's go ahead and do the domain and the range. So the domain, whenever you read the domain, you want to read it from the left to the right because you should always be going from the least numbers to the greater numbers, least to greatest. So on the left side, you see an arrow. That means it's going to negative infinity. So the x values are going to the left, negative infinity. Now let's see what happens here. At negative 1, there is a closed circle at negative 1. So negative 1 is included in the domain. And then it just goes to the right from here. So this is also going to infinity. So this is also all real numbers. Every x value imaginable is included in this graph. Okay, don't let that open circle throw you off. Now, let's talk about the range. Range, you want to read the y values. So you read the range from the bottom to the top, okay? That's least to greatest. If you look at the y-axis, the numbers on the bottom are smaller, and then they get greater as you go up. So we're going to start at the bottom. So at the bottom here, I'm going to erase this a little bit so we can see it clearly. This is an open circle at -4, okay? That's an open circle. So the very bottom of this graph is at -5, right there at -5. So I know that my y value, it includes -5, and I'm going to use the union symbol. It jumps up to -4 right there. That open circle is at -4. So I have -4, and it's a parenthesis because that's an open circle. And then it shoots up from there. It goes up to infinity. So that is my range. Now, let's talk about this jump right here. This little jump, this union symbol. Notice in my graph, there's no line right here. I'm not including numbers like -4.5 or -4.9. Those numbers are not included in this graph, okay? Uh-oh. There is a jump. It skips over those numbers. Your range, your y values, it only includes -5. It skips these numbers in between, and then it goes on to -4 and then goes up from there. Okay? So that is why your range has this jump right here. It goes from -5 and then it picks up again at -4. The other way to write this is you can say all the y values such that your y value equals -5 and your y values are greater than -4. Okay, this is called set notation. Set notation. This is called interval notation. When you use parentheses and brackets to represent the domain and range, that's called interval notation. Okay? All right. I'm going to do some more examples with you guys. So let me try to go to another page. Here we go. All right. Let's do a harder one. Let's do this one right here. Okay. So this is saying y equals -3x. So I'm going to go ahead and graph it here. So I start there, right there at the origin. Okay. And I'm going to go down 3 over 1, down 3 over 1. I can also continue in this direction. So this is my line. Now let's look at the constraint. It says that it only wants this line for when x is less than 0. So I don't want this side. I just want it at x equals 0. So it's just going to start there. And notice, guys, it's going to be an open circle at 0. Let me make a smaller. Let me make a thinner pen. At 0, it's going to be an open circle. Okay? Because this is only a less than sign, not a less than or equal to sign. So that's our first line. Let's do the next one. Our next line is -1/2 x minus 1. So I'm going to start at 1, right there, at -1. And I'm going to go down 1 over 2. That's my slope, -1/2. So that's my line. Okay, so now let me draw my line. Okay, so that's the line, -1/2 x minus 1. But it only wants this line between 0 and 6. And it says equaling 0, but not equaling 6. So let me just erase. I don't want this side. I only want it between 0 and 6. So I don't want this side either. I just want between 0 and 6. And at 0, I will have a closed circle because there is an equal sign underneath this symbol. And this one will be open. So this will be an open circle at 6. Now let's go ahead and graph the next line. I'll do it in blue. So this one is x minus 7. So I'm going to go down to negative 7. 1, 2, 3, 4. Right here, I believe. Right there. And my slope is just 1, up 1 over 1. So this is my slope. All right, so this is my line. However, let's look at the constraint. It says it only wants x when it's greater. It only wants this line if x is greater than 6. So I'm going to erase this side because these are all x values that are smaller than 6. I don't want these. I only want it where x is greater than 6. So up until there. Uh-oh. And this will be a open circle at the 6. So that'll be like that. Okay? All right, so that is my piecewise function. Let's go ahead and do the domain. So the domain are all of the x values. The x values represented in these piecewise functions. All the x values represented on the graph, okay? And it can be on any line. It doesn't matter. So we always, for domain, you always read it from the left to the right. So we're going to start on the left-hand side. On the left-hand side, there's an arrow. So that means it's going to go to negative infinity, okay? And that is a parenthesis. Let me write that a little neater. It goes from negative infinity to, let's see what happens on as we move forward. Right here, there's a closed circle. So we can include 0 in our domain, and then it continues and it goes to 6. At 6, there are open circles, so we stop at 6. We cannot equal 6. And then from 6, there's an arrow, so it'll go to infinity. Okay? The reason why I stopped at 6 and continued on the other side of 6 is because we cannot equal 6. There are open holes right here. We do not include 6. Okay? We can have 5.999. We can have 6.0001, but we cannot have the number in the middle. We cannot have 6. It can equal this, and it can equal this number, but it cannot be 6, okay? Because those are open circles there. So we get really close to 6, but we don't touch it. So that's how you write it in interval notation. This is how you'll do it in set notation. So set notation, I'm going to say all of the x values where it can be any number except for 6. Any number is fine except for 6. So that's how I write it in set notation. This is called set notation. This one is called interval. All right, now let's do the range. Okay. Oh, okay, let me just keep the graph like it is. Okay, let's do the range. Range, you read it from the bottom to the top. So bottom to the top. So at the very bottom is right here. This is the bottom of the graph, and that's at -4. So I know the bottom's at -4. Okay, let's see what happens. Something interesting happens here at -1. There's a closed circle here, but an open circle here. Well, closed circle always wins, so -1 is represented. So we can keep going. Now, I want to point out something interesting here. I don't know if I can show it clearly or well enough. Let me redraw this. Okay. After -1, this line covers all the y values between -1 and 1, and it goes on forever. This line also goes on forever. So guys, this goes from -4 to infinity. Yes, I know there is an open circle right here, but there are closed points on this line. I made that too thick. There are closed points on this line. There are points on this line. So there are y values right here, even though there's an open circle here, okay? So this goes from -4 to infinity. You can also write it in set notation. So I'm going to say y such that y is greater than -4. Okay, so that's how you do the domain and range. I can do another example for you guys if you need to. So how about I do this one? Actually, I'll do this one. All right. So y equals 2x. So that is this line here. Just plot the line. Uh-oh, didn't mean to do that. Go up 2/1. All right, so that is my line. And if you're doing this on paper, following along with the notes, then make sure you do this with a light pencil so you can erase things. So I only want this line for when x is less than or equal to -2. So, well, here's -2 right here. So that means I don't need any of this side because all these x values are greater than -2. So I'm going to go right up to there. And it looks like it'll be a closed circle. So I was fine right there. It'll be a closed circle. Okay, now let's look at the next thing. My next line is -1, -x. So I'm going to start at -1. And I go down 1/1. So this is my line. And I'll continue this way. Okay, and it is saying that it only wants this line between -2 and 4. And those are going to be open circles because there's no equal signs on those inequalities. So -2 and 4. That means, let me show you where -2 and 4 is on my number line. This is -2 and this is 4. So I only want the line between those points, okay? All right, so I'm going to erase these points because that is outside of -2. That's smaller than -2. And I'm going to get rid of that point. I only want them between -2 and 4. So this is my line. I'll go ahead and connect the points. First of all, this point will be an open circle. Oh, that's too big. An open circle. And then this one down here will be an open circle. There we go. Now just connect your line. Draw yours prettier than mine. Okay. So that was the second equation. Let's do the last one. This says y equals -3. So this is the y-axis and -3 is right here. So that means this is a solid line that goes through -3. I'll scoot over. So this is the line, and actually let me do it in a different color. This is the horizontal line that goes through -3. So I'll do this in blue. So here's -1, -2. Okay, so right here. So this is the line that goes through -3. But I only want it when x is greater than or equal to 4. So I'm going to erase all of this because I only want this line for when it's greater than 4, greater than or equal to 4. Here's 4 right here. So I'm going to start the line here. And it'll be a closed circle because that's a greater than or equal to symbol. All right, so that's my piecewise function. Let's go ahead and do the domain and range. Remember, domain is from left to right. So on the left side, I have an arrow. So that'll be -infinity. It's okay. This is let me highlight it. This is a closed circle at -2. So -2 is represented. All the numbers after -2 is represented in this red line. And once it gets to 4, this line picks it up. It's a closed circle and it goes on forever. So it looks like the domain is all real numbers. You can write it like this in interval form, or you can write all real numbers. Okay? All right, now let's do the domain. We just did the domain. Let's do the range. Okay, so the very bottom of my graph, let me highlight. The very bottom down here, oops, I didn't mean to do that. The very bottom of my graph has an arrow. So that's pointing down to negative infinity. And let's follow this up here. It comes up here to -4. And this red line covers all of these y values. And the very top is right here at 1. So that goes from negative infinity to 1. That's an open circle up here, so I'll have a parenthesis. Okay? So that is my range. You can also write it in set notation. So you can say y such that all the y values are less than 1. Okay, so that's the range. And what the heck, I'll just go ahead and do this one too, since these are notes after all. How about I do this one? Actually, let's do a fraction. Okay, so I'm going to graph this line. So I'm going to start at -1. That's my y-intercept, -1. And I go down 5 over 2. So that's that point, and I'll be there somewhere. Okay, so this is my line. Okay, and it says that it only wants this line if x is less than 2. So let me remind you, on the x-axis, this is 2 on the x-axis. And it wants the line when it's less than -2. I'm sorry, less than 2. So I'm going to erase this part of my line. I don't want to go past 2. And this will be an open circle. There we go. So that was our first one. Next, I have the line x plus 2. So let's go ahead and graph it. So I start off at 2 and I go up 1 over 1. So this is my line. I really don't have to go the other way because it only wants this line for x is greater than 2. So here is 2. That means I don't need anything that's less than. So these points, these x values are less than 2. I don't want those. And this is my line. Now notice this does not have an equal sign. So what does that tell you about this point right here? It needs to be open. Uh-oh. This point right here needs to be open. There you go. So that is how you do your piecewise graph. Now let's do the domain. Remember, the domain is all of the x values represented on this graph that we just drew. So on the left side, we have an arrow. So I'm going to have -infinity. Let's see what's happening as we go to the right. We go to the right, and then something interesting happens here. I have an open circle at 2 and an open circle at 2. So that means we cannot equal 2. So I'm going to put a parenthesis there, and we'll pick up on the other side of 2. And then we go on forever to the right. So that'll be 2 to infinity. So this is interval form, interval notation. Oh, I skipped a V. This is interval notation. Now let's do set notation. So x such that all the x values are okay, but x cannot equal 2. Okay? All right, now let's try the range. Range is bottom to top. So the very bottom of this graph is down here. And that's at -6. So the bottom is at -6. Let's see what happens at the top. Well, it just goes on forever. All the y values are represented here. It does not matter that there's an open circle here. That's okay, because there is an x value of 2. Oh, I'm sorry. What am I talking about? The y value right here. There is an open circle here at the y value 4. But it's okay because there's a point 4 on this graph. This is the point maybe -2, 4. So we have a y value represented here on this line. So you can just ignore that open circle. It goes to infinity. Okay? You can also write it in set notation, y such that y is greater than -6, right? Because everything is above -6, so everything is greater than -6. This is called set notation. Now, let me just remind you of something. Some of you guys have learned about inequality notation before. Actually, all of you have. Inequality is the same thing as set notation, just without the little fancy bracket. Inequality form would just be y is greater than -6. Set notation has these little fancy parentheses on them. So this is set notation, this is inequality notation, this is interval notation. Okay? All right, I want to show you guys one more thing before I end this recording. Okay. How about we work backwards? Let's say I gave you an equation. I want you guys to be able to think backwards. So let's say I have this line, and then I do something like this. The closed circle there. And then let's say I do this. Let's say I do this. Okay, so I give you the piecewise function. Now I want you to work backwards and give me the equations. So let's start. I have 3 lines. I have this line right here. So guys, what is the equation of this line? Well, if I were to continue this, oh, that crosses the y-axis at -4. So that's the equation. Y equals -4 is the equation of that horizontal line. And I only want it from the interval -8 to -4. And that's a closed circle at -4, so I'm going to put a line underneath. Okay, so that's the first line. Now let's do the next one. I have this line right here. It crosses the the y-axis at 4. So I know it'll be y equals something 4. And my slope, let's see what I did. It looks like I went up 2 over 1, up 2 over 1. So that's 2x. Okay? And this is the line between -4 and 0. This is the x value -4, the x value 0. So the interval is -4 to 0. And I have closed circles on both of those, so those will be lines underneath. Now let's do the other one. This line, the y-intercept is also 4. And then my slope, it goes down. Here's my line here, and here's my point there. So it goes down 1, 2, 3, 4, 5 over 2. So that's -5 over 2x. So that's my line. And it goes from -4 to 4. And that will not have a line underneath because this is an open circle. Now, what if I turn this into an arrow? Well, then just erase this part. And I'll just switch it over. You see how it's opening towards x? Make sure that it's opening towards x. Uh-oh. Oh, I made a mistake. Sorry. Okay, so this line right here, the interval is from 0 to 4. So it goes from 0 to 4, right? But if I turn this into an arrow, then this will go on forever. It'll go off to infinity. So you can write it like this, or you can just say x is greater than 0. Okay? All right, so that's working backwards. So if you missed class, hopefully this video helps you keep up with the pace and what we did today. Hope this video helped.